Hi guys, so today we're going to look at one new property for logs and exponents, and then we're also going to just review some of the properties that we did last week and get a little bit more practice on them. So if you guys remember, one of the things that we talked about with inverses, if two functions are inverses of each other, then if I do composition, f of g of x is the same thing as g of f of x, and both of those things equal x. Well, let's say that f of x is log base b of x, and let's say that g of x is b to the x. Well, we know those two functions are inverses of each other. We've talked about that before. So what I'm going to do is I'm going to go ahead and actually do those two things to show you these inverse properties. So I'm going to do f of g of x. So that would be log base b of b to the x. Well, log base b of b to the x, because this is a composition, because those are inverses, that's going to equal x. Well, we also know, using those properties from last week, if I do x times log base b of b, log base b of b is just 1, which also gives me x. Okay, so that's true for two reasons. But knowing that it's true because of these inverse properties helps us to see this other one. If I do b raised to the log base b of x, because again, I'm doing g of f of x here, well, g of f of x also has to equal x. So b to the log base b of x is also x. So let's look at some of these practically. All right, let's look at 8 to the log base 8 of 4. Well, because the base and the base are the same there, 8 to the log base 8 of 4 is just 4. That's that inverse property. All right, then we'll look at this next one, okay? Log base 7 of 7 to the negative 3x. Now, you could work this out using the properties that we did last week. You can move that exponent to the front. Log base 7 of 7 is just 1, and you get negative 3x. But if you didn't want to show that work, you also could just use that inverse property, which tells you that exponent right there is going to be your answer. Again, that is considering, though, that this base is the same number as the base of that exponent there. So those numbers do need to be the same. All right, same thing on the next one. Again, the bases need to be the same. Well, this is e, and ln does have a base of e. So since those bases match, I get 20. So then what we need to consider is what happens if those bases aren't the same. Well, if those bases aren't the same, we have a couple options. So one option is I can rewrite the base so that it is the same. For example, on this one, in order for me to use that property, this needs to be a base of 2. Well, I can rewrite 8 as 2 to the third. That's now multiplied by log base 2 of 7. Well, now again, my answer here, though, is not going to be 7 because I have that 3 out front. So this would become 2 to the log base 2 of 7 to the third. So my answer here would be 7 to the third, which is 343. All right, let's look at this next one. So this one's a little bit different. Now, it's kind of hard to rewrite. I can't write 8 with a base of 4. And it's going to get really messy if I try and write this base as 2 squared. We don't want to get into that. What I can do instead, look at the log that you have here. Log base 4 of 4 is something that we know. Log base 4 of 4, okay, again, just look at that independently. 4 to the something power is equal to 4. That something power is 1. That means log base 4 of 4 is just 1. So this whole thing is just 8 to the first power, which is just 8. All right, and this last one, very similar. The base is already matched, but again, I do need to take care of that 3 and move it. So this would become e to the natural log of 5 to the third. So my answer here, because e and e, same bases, my answer would be 5 to the third, which is 125. All right, so that's really it for the notes part of today. Again, pretty short. A lot of time is going to be spent on this assignment that's really reviewing, kind of combining these properties together and reviewing what we did last class. So one thing I will tell you on the practice assignment that you guys have, it gives you a chart that has about 6 different logs given. I will tell you, you do not need to use that chart for every single problem. There are many problems that you're going to do that don't need that chart. But I'm just going to work through one of these examples just so you guys can kind of see how these work. What we want to do is, again, simplify this to just a decimal. We should be able to evaluate it using logs that we either know without a calculator or using the values that are in this table. Now, I will tell you, this is an assignment where every single one of these problems needs to have work. Now, it may not be a ton of work. It may just be 1, maybe 2 steps, but there needs to be some work shown to show your process and how you got there. There's also more than one way to get to your correct answer. Just keep in mind, the only logs that you know that are not whole numbers or fractions or easy ones we can get using exponent rules are these logs here. So don't use a calculator to evaluate some other log. Like, I'm not going to use a calculator to evaluate log base 3 of 30. All right, I'm assuming the only ones I know are these ones here. All right, so let's go ahead and work out one of these problems that you'll see on your assignment. So log base 3 of 30, I do not know. What I do know is log base 3 of 10. And that's the only log base 3 besides 2 that I know. So I got a couple options here. What I'm going to do, since I know log base 3 of 10, I'm going to rewrite this as log base 3 of 3 times 10. So this becomes log base 3 of 3 plus log base 3 of 10. And then log base 4 of 4 to the 5th, that's that new inverse property. That's just 5. So log base 3 of 3, it's not on my chart, but it's one that I know. 3 to the first power is 3. Then log base 3 of 10, that's when I'll use this chart. And then from here, it's just some simple math with my decimals. If you want to use a calculator to evaluate these decimals, that's fine, just for time's sake. Again, more than likely, if you see these types of questions on an assessment coming up, it'll probably just be with variables instead anyway. It's more important that you understand how we break it down than necessarily getting those decimals right. But on this one, I end up with a negative 1.9041. So again, in this particular case, I did need this chart. There are many of these questions on this practice where you don't actually have to use that chart. So just because it's there, it's a resource for any logs that you don't know. So for example, I don't know 5 to the what power is 3. That's why that one's given. All right, so your to-do, pretty similar. It's pretty simple. What we've done last week. Take your notes, really short this week. Work the practice problems. That's the majority of today's work. You are going to submit these again. The answers are provided, but you have to show the work. All of these are going to have work on them, okay? It may not be, some of them may be small work. It may show like 5 plus 3 minus 1, but at least show that step, okay? So every one of these needs to have a minimum of 1 step. Some of them will just have the 1, but at least show that part. If you need help in the practice problems, you can email me or you can fill out that video request by 4 p.m. Also, if you guys watch the little welcome video for the day, there will be an opportunity more than likely for some sort of video chat type question session. We're still working out the details at this point, but by the time I post that welcome video, the details will be in there. And then other than that, just complete that 2A check by Friday. And that's, again, the one that's going to be graded for accuracy, kind of like our homework checks. All right, good luck, and please let me know if you guys have any questions.